This presentation will provide you with an overview of the quantitative reasoning measure. We'll start with reviewing the key elements of the quantitative reasoning measure and then consider question types and strategies for answering questions as well as the calculator. The quantitative reasoning measure of the GRE General Test assesses your basic mathematical skills, understanding of elementary mathematical concepts, and ability to reason quantitatively and to model and solve problems with quantitative methods. The major areas of knowledge expected are arithmetic, algebra, geometry, and data analysis. Some of the quantitative reasoning questions are posed in real-life settings, while others are posed in purely mathematical settings. Many of the questions are word problems, which must be translated and modeled mathematically. The skills, concepts, and abilities are assessed in the four content areas of arithmetic, algebra, geometry, and data analysis. Arithmetic topics include properties and types of integers, such as divisibility, factorization, prime numbers, remainders, and odd and even integers, arithmetic operations, exponents and roots, and concepts such as estimation, percent, ratio, rate, absolute value, the number line, decimal representation, and sequences of numbers. Algebra topics include operations with exponents, factoring and simplifying algebraic expressions, relations, functions, equations, and inequalities, solving linear and quadratic equations and inequalities, solving simultaneous equations and inequalities, setting up equations to solve word problems, and coordinate geometry, including graphs of functions, equations and inequalities, intercepts and slopes of lines. Geometry topics include parallel and perpendicular lines, circles, triangles, including isosceles, equilateral, and 30-degree, 60-degree, 90-degree triangles, quadrilaterals, other polygons, congruent and similar figures, three-dimensional figures, area, perimeter, volume, the Pythagorean theorem, and angle measurement in degrees. The ability to construct proofs is not tested. Data analysis topics include basic descriptive statistics such as mean, median, mode, range, standard deviation, interquartile range, quartiles, and percentiles. Interpretation of data in tables and graphs such as line graphs, bar graphs, circle graphs, box plots, scatter plots, and frequency distributions. Elementary probability, such as the probabilities of compound events and independent events. Conditional probability, random variables and probability distributions, including normal distributions and counting methods, such as combinations, permutations, and Venn diagrams. These topics are typically taught in high school algebra courses or introductory statistic courses. Inferential statistics is not tested. The content in these areas include high school mathematics and statistics at a level that is generally no higher than a second course in algebra. It does not include trigonometry, calculus, or other higher level mathematics. The test contains two 35-minute sections. Each section has 20 questions. There are four types of questions: multiple choice, where you can select one answer; multiple choice, where you can select one or more answers; quantitative comparison questions; and numeric entry questions. Some questions involve interpreting data sets. There are several questions about the data presented. The quantitative reasoning measure of the computer-delivered test is section-level adaptive as well. If you perform better on the first section, you will experience more challenging questions in the second section. Within each section, all questions contribute equally to the final score. Both sections are important since the final score is based on the total number of correct answers and the level of the difficulty of questions. The quantitative reasoning measure has four types of questions: multiple choice questions, select only one answer choice; multiple choice questions, select one or more answer choices; quantitative comparison questions; and numeric entry questions. Each question appears either independently as a discrete question or as part of a set of questions called a data interpretation set. All of the questions in a data interpretation set are based on the same data presented in tables, graphs, or other displays of data. Multiple choice questions. Select one answer choice. Use the fact that the answer is there. If your answer is not one of the 5 answer choices given, you should assume that your answer is incorrect and do the following. Reread the question carefully. You may have missed an important detail or misinterpreted some information. Check your computations. You may have made a mistake, such as miskeying a number on the calculator. Reevaluate your solution method. You may have a flaw in your reasoning. Examine the answer choices. In some questions you are asked explicitly which of the choices has a certain property. You may have to consider each choice separately, or you may be able to see a relationship between the choices that will help you find the answer more quickly. In other questions, it may be helpful to work backward from the choices, say by substituting the choices in an equation or inequality to see which one works. However, be careful, as that method may take more time than using reasoning. For questions that require approximations, scan the answer choices to see how close an approximation is needed. In other questions, too, it may be helpful to scan the choices briefly before solving the problem to get a better sense of what the question is asking. If computations are involved in the solution, it may be necessary to carry out all computations exactly and round only your final answer in order to get to the required degree of accuracy. In other questions, you may find that estimation is sufficient and will help you avoid spending time on long computations. Here's an example. A car got 33 miles per gallon using gasoline that costs $2.95 per gallon. What was the approximate cost in dollars of the gasoline used in driving the car 350 miles? The options are $10, $20, $30, $40, or $50. It is possible to work this out precisely, but as you're being asked for the approximate cost, it makes sense to work in approximate terms. A car traveling 330 miles at $2.95 per gallon would make the cost $29.50 because it is 10 times both 33 miles and the cost per gallon, $2.95. An extra 20 miles is going to be less than $2.95 because the car can go 33 miles per gallon. Thus, the approximate cost is about $30. Multiple choice questions. Select one or more answer choices. These questions are multiple choice questions that ask you to select one or more answer choices from a list of choices. A question may or may not specify the number of choices to select. Some tips for answering. Note whether you are asked to indicate a specific number of answer choices or all choices that apply. In the latter case, be sure to consider all of the choices, determine which ones are correct, and select all of those and only those choices. Note that there may be only one correct choice. In some questions that involve conditions that limit the possible values of the numerical answer choices, it may be efficient to determine the least and/or the greatest possible value. Knowing the least and/or greatest possible value may enable you to quickly determine all of the choices that are correct. Avoid lengthy calculations by recognizing and continuing numerical patterns. Let's look at another example. Last year, Kate spent between a quarter and a third of her gross income on her mortgage payments. If Kate spent $13,470 on her mortgage payments last year, which of the following could have been her gross income last year? Indicate all such gross incomes. The options include $40,200, $43,350, $47,256, $51,996, $53,808. We first need to calculate the range of what Kate spent in this example. Her total income is between 4 times and 3 times $13,470. Therefore, the range of her gross income must be between $40,410 and $53,880. This means that all of the gross incomes except $40,200 could have been her gross incomes last year. Quantitative comparison. Questions of this type ask you to compare two quantities, quantity A and quantity B, and then determine which of the following statements describes the comparison. Quantity A is greater, quantity B is greater, the two quantities are equal, the relationship cannot be determined from the information given. Let's look at an example. In this situation, we see a triangle PQR and another triangle SQR inside this. We cannot assume that the lines are to scale in these questions, and so it might look as though the line QS intersects through the middle of the line PR, but we cannot be sure. Therefore, quantity A, the line PS, and quantity B, the line SR, may not be the same, as the line QS does not necessarily intersect through the middle of PR. Thus, the correct answer is the relationship cannot be determined from the information given. Become familiar with the answer choices. Quantitative comparison questions always have the same answer choices, so get to know them, especially the last choice. The relationship cannot be determined from the information given. Never select this last choice if it's clear that the values of the two quantities can be determined by computation. Also, if you determine that one quantity is greater than the other, make sure you carefully select the corresponding choice so as not to reverse the first two choices. Avoid unnecessary computations. Don't waste time performing needless computations in order to compare the two quantities. Simplify, transform, or estimate one or both of the given quantities only as much as is necessary to compare them. Remember that geometric figures are not necessarily drawn to scale. If any aspect of a given geometric figure is not fully determined, try to redraw the figure, keeping those aspects that are completely determined by the given information fixed, but changing the aspects of the figure that are not determined. Examine the results. What variations are possible in the relative lengths of line segments or measures of angles? Plug in numbers. If one or both of the quantities are algebraic expressions, you can substitute easy numbers for the variables and compare the resulting quantities in your analysis. Consider all kinds of appropriate numbers before you give an answer, e.g. 0, positive and negative numbers, small and large numbers, fractions, and decimals. If you see that quantity A is greater than quantity B in one case, and quantity B is greater than quantity A in another case, choose the relationship cannot be determined from the information given. Simplify the comparison. If both quantities are algebraic or arithmetic expressions and you cannot easily see a relationship between them, you can try to simplify the comparison. Try a step-by-step simplification that is similar to the steps involved when you solve the equation. Numeric entry. Questions of this type ask you either to enter your answer as an integer or a decimal in a single answer box, or to enter it as a fraction in two separate boxes, one for the numerator and one for the denominator. In the computer-delivered test, use the computer mouse and keyboard to enter your answer. Here's an example. A merchant made a profit of $5 on the sale of a sweater that cost the merchant $15. What is the profit expressed as a percentage of the merchant's cost? Give your answer to the nearest whole percent. The profit is $5 and the cost of the sweater is $15. $5 divided by 15 is 0.3333. Repeated. Expressed to the nearest whole percent, this is 33%. Make sure you answer the question that is asked. Since there are no answer choices to guide you, read the question carefully and make sure you provide the type of answer required. Sometimes there will be labels before or after the answer box to indicate the appropriate type of answer. Pay special attention to units such as feet or miles, to orders of magnitude such as millions or billions, and to percents as compared with decimals. If you're asked to round your answer, make sure you round to the required degree of accuracy. For example, if an answer of 46.7 is to be rounded to the nearest integer, you need to enter the number 47. If your solution strategy involves intermediate computations, you should carry out all computations exactly and round your final answer in order to get to the required degree of accuracy. If no rounding instructions are given, enter the exact answer. Examine your answer to see if it is reasonable with respect to the information given. You may want to use estimation or another solution path to double-check your answer. Data interpretation questions. Data interpretation questions are grouped together and refer to the same table, graph, or other data presentation. These questions ask you to interpret or analyze the given data. These types of questions may be multiple choice, both types, or numeric entry. Take a moment to look at the following example. The question asks if each of the average ratings was the arithmetic mean of the ratings given by the 100 travel agents. Approximately how much greater was the total of the ratings given to all three airlines for reliability than for promptness? The first step is to determine the difference between the average ratings of reliability and promptness. Promptness equals 17.5, reliability equals 20.2. To determine the difference, we deduct 17.5 from 20.2, giving ours 2.7. As this is based on the ratings given by 100 travel agents, we can multiply 2.7 by 100 to get 270. Therefore, the ratings given to all three airlines for reliability was about 250 ratings higher than for promptness.
Strategies for data interpretation questions.
Scan the data presentation briefly to see what it's about, but do not spend time studying all of the information in detail. Focus on those aspects of the data that are necessary to answer the questions. Pay attention to the axes and scales of graphs, to the units of measurement or orders of magnitude such as billions that are given in the titles, labels, and legends, and to any notes that clarify the data. Bars, graphs, and circle graphs, as well as other graphical displays of data, are drawn to scale, so you can read or estimate data visually from such graphs. For example, you can use the relative sizes of bars or sectors to compare the quantities that they represent, but be aware of broken scales and of bars that do not start at 0. The questions are to be answered only on the basis of the data presented, everyday facts such as the numbers of days in a year and your knowledge of mathematics. Do not make use of specialized information you may recall from other sources about the particular context on which the questions are based, unless that information can be derived from the data presented.
On-screen calculator on the computer-based test.
You are allowed to use a basic calculator on the quantitative reasoning measure. For the computer-delivered test, the calculator is provided on screen. Most of the questions don't require difficult computations, so don't use the calculator just because it's available. Use it for calculations that you know are tedious, such as long division, square roots, and addition, subtraction, or multiplication of numbers that have several digits. Avoid using it for simple computations that are quicker to do mentally, such as 10 minus 490, 4 multiplied by 70, 4,300 divided by 10, the square root of 25, and 30 squared. Avoid using it to introduce decimals if you're asked to give an answer as a fraction. Some questions can be answered more quickly by reasoning and estimating than by using the calculator. If you use the calculator, estimate the answer beforehand so you can determine whether the calculator's answer is in the ballpark. This may help you avoid key entry errors.